let's talk about simplifying radical expressions. This is a lot of notes all at once, but I want you to notice in this section we have 4 examples. Those are the 4 types of problems we're going to be doing. Here's one worked out already. And what we've done is we've applied a few of our properties of square roots. Okay, when we deal with radicals, what we can do is we can apply the product rule for radicals, which means that anything that is multiplied, a product, we can split it up. That's the product property. You'll notice that there's another property very similar, that is the quotient property, that says we can do that with fractions as well. If we have 2 things that are divided, we can combine them, or if we have 2 things that are in one radical, we can split them up into 2, okay? The other thing we want to watch out for is the power property when we're looking for powers. So I want to walk through these 4 examples. First up, I want you to remember that when we don't have an index labeled, we like to imagine there's a 2 there. Okay, so I'm going to go ahead and split this up into sets of 2. If I do that, then I would have x squared times x squared times x squared, because 2 plus 2 plus 2 would give me 6. So x to the 6th is the same as x squared times x squared times x squared. I also have y squared times y squared, but now I have a times y to the 1, okay? So notice that it doesn't have a pair. When we go ahead and do this, what we're going to do is we're going to split this into our properties, and then I'm going to square root each one. Square root of x squared, well, that's just x. The square root of x squared, the square root of x squared, and so we end up with x to the 3rd, x times x times x. We can take the square root of y squared, and we can do that twice, and that's going to give us y squared. And then we have one last piece, this square root of y to the 1, and since that doesn't match up, we're just going to leave it just like that. So our simplified answer looks like that. To kick it up a notch, I'm going to do 2 things here. One, I'm making 3 different variables and also numbers, okay? So we've put a coefficient in there. What we're going to do to actually make this simpler is we're going to focus on one piece at a time. You can almost treat this just like it was square root of 125, the square root of x to the 4th, the square root of y, and the square root of z to the 5th. So if when you have all these things under there, our product property says that we can multiply them. If they're multiplied together, we can pull them apart into separate square roots. Now, this makes it a little bit easier, so I'm going to first simplify the 125. So that would be like 25 and 5. So the square root of 125 is like the square root of 25 and the square root of 5 multiplied together. Again, using that product property. I know that the square root of 25 is 5. The square root of 5 is unfortunately just square root of 5. It's a prime number, it doesn't square root. When I look at x to the 4th, we can say, well, that's the square root of x squared and the square root of x squared multiplied together. So that is simply x times x, or x squared. And there's nothing left underneath the square root. Square root of y, we already talked about how that does not simplify, so I'm just going to leave it square root of y. And the last one, we have z to the 5th. And so what I want you to notice is that the z to the 5th is not going to simplify down to a whole number. In other words, if I were to take 5 and divide it by 2, I would get 2 and a remainder of 1. So I'm going to get z squared square root z. So I got 1z left over, just like we did on the last problem. Now, this was all together. So in order to finish this problem, I'm going to put these all back together. What goes on the outside, I'm going to keep on the outside. What goes on the inside, I'm going to keep on the inside. So I'm going to get 5x squared z squared, and then the square root of 5yz. We can make this slightly more difficult by putting stuff on the outside of the square root to begin with. Okay, so the good thing is we're going to leave it on the outside. Let's go ahead and simplify it with that negative 5 on the outside, and let's deal with the numbers first. I need to divide 18, and I'm going to say that's 3 and 6, and 3 and 2. So notice that we have a pair of 3's and a 2 left over. Okay, So that means I'm going to put those pair of 3's outside. But since I already have a -5 out there, they're multiplied. So that's going to end up giving me -15 square root of 2. Notice that square root of 2 is left on the inside because it doesn't pair up. The next part I'm going to do is I'm going to do the x, the y, and the z. I'm going to do them all together because they are all even. Okay, so you notice that when we're doing the square root of something that's even, remember the index implied is 2. So we say, oh, these are all even. How many pairs can I make? So I can just divide each of these by the index, or divide each of them by 2. And so that ends up being x squared, y to the third, and z to the fifth. There's no remainder. There's no odd numbers. And so that ends up being beautiful. Now I'm going to combine these two pieces right here to go ahead and put the -15 square root of 2. But I want to combine them by making sure the outsides stay on the outside. So I'm going to put this stuff on the outside with it. And the square root of 2 is the only piece that's left on the inside. One last one. Let's kick it up a notch. So I want you to notice when we do this one, what could make it more difficult? Well, we could take the 4th root. Okay. Now remember that trick we just did where we said we can divide these by these? In other words, how many 4's go into 13? Well, I know that 3 times 4 is 12, and there'd be 1 left over. So if I do 13 divided by 4, then that's going to give me a to the 3 with an a left over in the square root, or in this case, in the 4th root. Let's try again with the 23. So 23 divided by 4, well, that is 5. And how much is left over? 5 times 4 is 20, so that's a remainder of 3. So I'm going to say a to the 3rd power, not just 1 in there. It's to the 3rd power. Sorry, it should be b. It's always frustrating when you get the right answer and then your letters are wrong, because a computer would just grade you wrong. Let's look at the c. c is to the 10th. It also doesn't divide by 4. So we get c squared. 2 times 4 is 8, plus 2. So there would be 2 left over. And the last one, d to the 3rd. d to the 3rd, actually, you can't get any sets of 4 if you've only got 3 to begin with. So we're going to leave it right there. Now I'm going to put it all together so that I get one beautiful shape, one beautiful answer. But I need to put the outsides on the outsides and the insides on the insides. I'm going to keep it in the same alphabetical order. So I'm going to have a cubed, b to the 5th, c squared. Then I have the 4th root of a, b to the 3rd, c squared, d to the 3rd. All right, I think you are ready to try these on your own. Try to simplify these. Feel free to drop them in the comments below and see if other people agree with you. Check yourself with the other people. Thank you so much. I'll catch you next time. Like and subscribe.